The high-lift devices consist of leading-edge slats and trailing-edge flaps. The leading-edge slats are mechanically connected and operated by a power drive unit. A second power drive unit operates the trailing edge flaps, which are also mechanically connected. The flap lever controls the flap power drive unit, which in turn controls the slat power drive unit. The two power drive units are powered by the left hydraulic system. Shutoff valves control hydraulic pressure to each unit. If pressure is not available, electric motors can operate the power drive units via the alternate slat and flap system. Should the left hydraulic system lose pressure, the power transfer unit can operate the flaps and slats as a backup. Amber leading edge lights, trailing edge lights, and flap position indicator are located on the center panel. The leading edge light illuminates, accompanied by the associated caution alerts, indicating either a slat disagreement or a slat asymmetry condition. Either condition automatically shuts off hydraulic power to the power drive unit. The trailing edge light illuminates, accompanied by the associated caution alerts, indicating either a flap disagreement or a flap asymmetry condition. Either condition automatically shuts off hydraulic power to the power drive unit. The flap lever is located on the center pedestal. The lever has 7 detent positions from 0 to 30. The gates at 1 and 20 prevent inadvertent flap lever movement through these positions. Moving the flap lever from up to 1 provides takeoff slats and trailing edge flaps to go 1 degree. Moving the flap lever to the 5, 15, or 20 detent extends the trailing edge flaps to the selected position. The leading edge slats do not move and remain in the takeoff position. Moving the flap lever to 25 selects landing flaps and slats. Selecting flaps 30 provides full landing flaps. Selecting flaps 30 also arms a flap load relief system. When indicated airspeed exceeds the flap placard limit, the load relief system will automatically activate and retract the flaps to 25. The position indicator shows this movement, but the flap lever does not move. As airspeed is reduced below the placard limit, the flaps return to 30. Should the flap load relief system fail to operate properly, the trailing edge light illuminates and associated ICAS message appears. This occurs when the flaps do not retract to 25. The flaps 30 limit speed should be observed. The stall warning system activates with the slats and flaps in any configuration. If the slats are at the takeoff position, a stall warning also activates the auto slat system, which will extend landing slats. When the stall warning no longer exists, the slats will return to the takeoff position. A takeoff configuration warning consisting of a master warning light, a config light, a siren, and 4 possible ICAS warning messages will occur when the flaps and slats are not properly configured for takeoff, or if flap or slat position disagrees with lever position. Other conditions that cause a takeoff warning will be covered in the warnings lesson. The alternate flap system is next. The alternate flap system allows the power drive units to be operated by electric motors rather than hydraulic power. The system is armed with alternate flap-slat switches. Pushing the switches closes the leading edge and trailing edge hydraulic valves and arms the electric motors. An alternate flap selector is used to position flaps and slats. When the selector is moved, the power drive units electrically operate the flaps and slats. Consequently, additional time is required for alternate extension and retraction of the flaps and slats. Flap asymmetry and load relief protection is not provided during alternate extension. Slat asymmetry protection is provided, however. During alternate operation of the slats, the auto slat feature is inoperative because the hydraulic shutoff valves are closed. When the alternate flap selector is placed to the 20-degree position, increased stall margin is provided by the slats extending to landing position. Flight control shutoff switches are located on the accessory panel. Shutoff switches must be on for all flight operations and are for maintenance use only. Now try some questions. Let's now look at 767 differences. The 767 slat and flap operations are controlled by 3 power drive units supplied by center hydraulic pressure. One power drive unit operates the inboard slats, which are mechanically connected. The second power drive unit operates the outboard slats, which are also mechanically connected. A third power drive operates all the trailing edge flaps. The inboard and outboard trailing edge flap sections are mechanically connected. Moving the flap lever to the 1 detent starts leading edge slat extension. After all slats have extended to the takeoff position, the pointers move to the 1 position. The trailing edge flaps, however, remain retracted. On the ER, selecting flaps 25 or 30 arms the flap load relief system. If the selected flap's airspeed is exceeded, the flaps automatically retract to the 20 position. The position indicator shows this movement. but the flap lever does not move. The flaps will extend back to the selected position when the airspeed is reduced below the flap limit speed. On the 767, if the angle of attack continues to increase after the control column shakers activate, a control column nudger will move the control column forward. The 767 does not have an auto slat system. When the alternate flap system is used, slat asymmetry protection is not provided on the 767. The 767-300 aircraft has higher limit speeds for flaps 20 and 30. The 767-300ER aircraft has different limit speeds for flaps 1, 5, 20, 25, and 30. Now let's try a question.